So what is now the fourth generation of mobile communication systems, mobile phone systems? And what is the difference to 3G, 3.9G? Well, similar to IMT 2000, the ITU came up with the idea of IMT Advanced and said, okay, IMT Advanced, all the systems that are members of this family should have certain features. So they should be, well, flexible, should support different services, application, cost effectiveness, etc. Should be compatible to certain services, should be, well, interwork with other systems, other radio access systems, should offer certain high qualities, etc., etc., worldwide use of user equipment, things we already wanted to have for the third generation, well, roaming, worldwide roaming, and now that's one of the important features, peak data rates should be something like 100 megabit per second for high mobility, a gigabit per second for low mobility. So that was the target. And if you compare this with LTE, you will see, well, LTE does not reach 1 gigabit per second. I explained something like, whatever, 300 megabit per second. So not really 1 gigabit per second. And this is one of the reasons why the classical LTE is not a 4G system. So LTE does not reach the 1 gigabit per second. So that's the idea. The idea there was, according to ITU, we want to address the evolving user needs and the capabilities, and everything should be enhanced with the user trends, etc., etc. So that was the idea. But in contrast to the third generation, we did not see a family of many different competing standards. I would say, well, industry and everyone learned a lot from this battle. So industry came up with LTE Advanced. LTE Advanced, well, is one of the candidates for IMT Advanced, and that's basically the system today for IMT Advanced. And that covers the releases 10, 11, and 12 of 3GPP. That's LTE Advanced. We saw release 8, that was the basic release for LTE. For LTE Advanced, it's now release 10, 11, 12. And that's a real 4G system. So here we see the real 4G system. And sure, we had new releases, and that's where we come to LTE Advanced Pro. That's 4.5G, sometimes also called Pre-5G. So 4.5, these are the releases 13, 14. These are the steps towards 5G. And I will cover 5G in the end of the lecture, together with the outlook. So the idea there was of LTE Advanced, sure, worldwide functionality, roaming, compatibility with services, but now also interworking with other radio systems. So Wi-Fi, wireless LANs, so LTE can make use of unlicensed spectrum to increase data rates, can combine wireless LAN LTE technology. The data rates are higher, 100 megabit, 1 up to 3 gigabit per second for low mobility, not for this 350 kilometers hour, but, well, at least 100 megabit per second for high mobility. So that's the idea. What else is new? That's not only the proposal for LTE Advanced, that's really something new in it. Increased coverage, relay nodes. That's something new. So you can relay your data to increase the coverage. That's important for rural areas, the countryside. So you can increase the, well, virtually the cell radius by creating new cells. LTE now offers so-called machine-type communication. So for machine-to-machine communication, that's different from having the highest data rates or voice communication or video. I will give you examples for this. But also LTE now offers certain public safety features. Remember TETRA? Now we have public safety features, for example, for device-to-device communication. So LTE Not all the devices using LTE, but the standard LTE offers device-to-device communications. And also fast call setup, push-to-talk. So device-to-device, that was exactly what we needed, for example, in emergencies. That's what Tetra offers. So you see, you could replace parts of Tetra, the special requirements, now with the new LTE standards. LTE also now, the Advanced and Advanced Pro, offers higher data rates, but that comes with higher bandwidth requirements. Here you see 100 megahertz bandwidth. Well, that's quite a lot. That's 5 times the classical LTE with 20 megahertz. We can aggregate carriers, but we can also use different modes for increased battery life. Where do we need this? Well, you can use LTE for the Internet of Things. LTE itself is a scalable platform. What does it mean? Well, one way to go, that's what I was telling you over the last slides, is higher data rates. Higher, even more gigabits per second, using more and more of the spectrum. Okay, these are our classical Category 1 devices up to early LTE Cat 5, now more and more high data rate devices, gigabits per second. That's not that interesting for the Internet of Things. You also have to scale the system down in complexity, scale it down in power. Maybe not that mobile, not that high data rates. Machine type communication. Evolved MTC, machine type communication. So we have machines communicating with each other with a controller. So, well, there maybe we need data rates up to a megabit per second, not gigabits per second. This is where we can use only a part of the spectrum, 1.4 megahertz, for example. Machines have enough energy. So energy is maybe not the problem, but we don't need these high data rates. Think of the Internet of Things, battery-driven devices. This is where we even have to scale it more down towards low power consumption. So we have narrowband IoT, NB-IoT, that means narrowband IoT. Narrowband, we use only 200 kilohertz. 200 kilohertz, that sounds familiar. That's what we use in our GSM systems. Okay, and tens of kilobit per second, that's also familiar for GSM, but now we use LTE. What is the advantage? Battery life. I will come back to this. So how can you now implement narrowband IoT? Well, we can squeeze it, that's called in-band. We can squeeze it in our regular broadband LTE spectrum. So we can squeeze it into the 20 megahertz band. So 20 megahertz, that's quite a lot. We need only 200 kilohertz out of this. Or if we have different LTE operators, we can squeeze it into the so-called guard bands between the 20 megahertz bands. So that's where we can squeeze it in. Or we can have standalone narrowband IoT spectrum. So for example, you could have GSM channels, you know them, our 200 kilohertz channels, GSM here, GSM there. And then within the GSM cell, we can pick one of the channels and say, okay, we don't use this for GSM, but we reuse it for LTE, now narrowband LTE. So that's a quite clever idea that we can reuse parts of the GSM. So the more and more users go to LTE, the fewer channels we need in our old GSM network, and then maybe we just leave some of the channels for these devices using GSM. Some other devices already use narrowband IoT. So you see, again, a smooth transition path from the old to the new technology. So LTE does not only mean higher data rates, but also way lower data rates and narrowband technology. Why do we do this? Well, battery, runtime. The problem with LTE, the normal LTE, but also let's say Wi-Fi or other technologies, power consumption. So you cannot run a device on batteries for, let's say, 10 years and more using Wi-Fi or classical Bluetooth or GSM or whatever. 10 years, well, that's quite long. With LTE, there are different schemes supporting this. So for the IoT devices, it's extremely important that they can sleep a lot, sleep almost all the time. So instead of waking up every 2-3 seconds, checking if there's data available, you can send a device into sleep for more than 40 minutes. You can transfer data and you sleep up, let's say, every 40 minutes, just to check if there's data at an access point. So that's quite important. So extended sleep times. And you also need different sleep modes, power sleep modes. Well, then the device is not reachable, but you need certain mechanisms to wake up the device, to monitor if data is available, transfer data, go to sleep again. So these mechanisms are not known from the classical GSM. Similar mechanisms are known from other IoT wireless systems, but now they're integrated in the LTE system. And that's what already some operators offer. You saw the statistics, around 80-90 operators already offer narrowband IoT, very important, not only for vending machines, but for sensors, for environmental monitoring, for animal monitoring, etc. I will come back to some other technologies like LoRa in later sections. So you see, LTE is quite flexible in terms of bandwidth requirements and offered data rates, but also delays. So looking back on LTE, why is it called evolution? What is evolutionary in LTE? Why is it not a revolution? So maybe some parts are revolution, but why is it more evolutionary? So, and how does the LTE reflect all those different demands in terms of data rates and bandwidth, etc.? And then please do have a look at the current status of LTE. So the story of LTE does not stop just because we now say everywhere, well, we have 5G. So check out the smooth transition path from the classical LTE, LTE Advanced, Advanced Pro, now more and more towards 5G. As I said, I will come back to 5G at the end of the lecture.